Here is another manometry problem, and this one is straight from the book. Problem 2.34 from Fundamentals of Fluid Mechanics, the 7th edition. So a lot of these problems are going to be from these textbooks and also from the lectures from classes that I took on fluid mechanics. So for this one, it's problem 2.34, and the question, well, we have a closed tank over here that's filled with water. So this whole thing over here is just water, and it's open on one end, and sometimes you'll see a triangle right here that denotes that it's an open air. So you want to determine the height in the open water column. This height right here is what we want to determine for part A. So that's what we want, and put a question mark right there. We also want the gauge pressure. If we put a gauge over here, what is that pressure? And additionally, the absolute pressure of the air, this air inside the tank, this one right here is 7 psi is in terms of gauge pressure. But what is the absolute pressure of that air? And so we're gonna pretty much just talk about that eventually. So over here, the PATM and the open air is PATM equals, it's given as 14.7 psi. I guess we'll skip, I think part C is, part C is probably the easiest one to answer. Let's start with part C. The formula for the absolute pressure, P absolute equals PATM plus P gauge. And PATM is 14.7 psi, and then the gauge pressure is 7 psi. Therefore, the absolute pressure of the air inside the tank is 21.7 psi. So that's probably the easiest one to answer. So we'll get letter C out of the way. And then now we're going to go to part A. Part A is a little bit trickier. So what we're going to do is we're going to use the swimming method again. And this time we're going to be swimming from this side. So I'm going to put a swimming guy over here. Pretend that's you're swimming. This is what we call the swimming method. So you're swimming from here up to here for part A. So we're going to put part A over here, and you're pretty much swimming from here up to this air right there. And we want to figure out what that H, the height, is over here. So what we're going to do is, so the pressure, we're going to start with the pressure over here, which is PATM. Actually, we're going to not call that PATM. We're going to call this 0.1. And then this is going to be 0.2, because PATM is equal to 14.7 psi, but we want this in terms of gauge pressure. So in terms of gauge pressure, that's going to equal, in terms of gauge pressure, this is going to just be 0, but we're going to try to be clear and show our equation, because your teacher probably will want you to show the equation or show your work. So from 0.1, and if we go all the way down to this point right here, you're going to increase in pressure. So it's going to be the specific weight of the water, since we're in the water, plus the height. And then we're going to swim horizontally over here, so there's no change in pressure. There's no net change in pressure as we swim horizontally. And as we swim up in the air, it's going to be negative because the pressure is decreasing. Specific weight of water. And then we know this as 2 feet. And that equals the pressure of the air, which is at 0.2. And in terms of gauge pressure, this is 7 psi. So now we're going to pretty much just move everything on the other side. We're going to solve for h. And if we solve for h, or we could actually just plug in the numbers and then solve for h, or we can solve for h and plug in the numbers. I usually like to plug in the numbers afterwards. So right now we're just going to solve for h. So we'll do that. We're going to move the P1 on this side and then this whole term on that side. Equals P2 minus P1 plus we'll move this term on the right side times 2 feet. And then now we're going to divide everything by gamma, H2O. So P2 minus P1 times specific weight of water. And if we divide this side by gamma, H2O, we're just going to get 2 feet on this side. So now this whole equation is in terms of feet, which is what we want. So now after we solve for h, now we're going to plug in the problem. And your P2 is going to be 7 psi. At this point right here, it's 7 psi. Okay, 7 minus 0, because PATM, remember, in terms of gauge pressure, this is, PATM is 14.7 psi, but in terms of gauge pressure, this is 0. So we're going to put 0 pound force per inch squared. And then we just want to make everything clear, so this is the way I like to do it with unit analysis. And then the specific weight of water is 62.4, which is given in your textbook, pound force per feet cube. This is going to cancel. This is going to cancel, and we want to be left with feet, so we're going to need to take away that inch squared. 12 squared, inch squared. We're going to use this conversion factor. 1 foot squared equals 12 squared, inch squared. That cancels. That cancels. We have feet squared over here and foot cube over here. That leaves us with feet, which is what we want. Plus, don't forget this term right here, which is 2 feet. And then now we have our units clear. Usually your teacher will want you to show all the units. And now it's just algebra at this point. And then if we plug that in the calculator, 7 times 60.4. The h is 18.115 feet. And that is our answer for part A. So just to recap part A. So we're swimming from point 1 to point 2. At point 1, the pressure gauge is 0, which is what we got right there after solving for h. So from P1, you're going to swim all the way down, and this is positive because the pressure is increasing as you're going down this pipe right here. So it's positive, specific weight of water times the height, which is what we want. And then as you're swimming horizontal, there's no change in pressure. So you're not gonna, you can put +0 if you want, but that's gonna be redundant. And then as you swim up, the pressure is decreasing, so it's minus specific weight of water times 2 feet. And that equals the pressure of the air. And then after solving for H, you get P2 minus P1 over specific weight of water plus 2 feet. Plug in your numbers, make sure you do your unit conversions, be very clear with the units. And then the height that you're gonna get is 18.15 feet. Next thing that we want for part B is what is the gauge pressure acting on the bottom of the tank surface? The tank surface. So this surface right here, we want the gauge pressure that's acting at the bottom of this tank. So we're going to do, for part B, we're going to do the swimming technique again. This time we're going to swim down from, we already called this point 2, so we're still at point 2 over here, down to point 3. We're going to call that point 3. And it's super helpful, especially during exams, that you draw a picture and you are clear with like the points, and you can draw your points, like just to be clear. So we're gonna swim from point 2 to point 3, and this should be a fairly easy problem. We want the pressure at point 3. So now we're gonna set up our formula, our equation. So let me just move this real quick. We already know what P2 is, which is 7 psi, but we're just going to try to be clear with the equation. So P2, if you're swimming from here all the way down to point 3, it's P2 plus, because again the pressure is increasing as you go down the water, so it's going to be positive specific weight of water plus 4 feet. You're going down 4 feet, and that equals your P3, which is the pressure that this surface is feeling. So if you swim from up here to down here, what is the pressure that you're going to be feeling once you're at this surface right here? So that's what we want. And P3 equals, we already got our P2. Our P2 is 7 psi up here. So it's 7 pound force. This is where you want to be very clear with your units. Plus specific weight of water, which is 62.4 pound force per cubic feet. And then it's 4 feet. You're going to be left with feet squared over here, but you want everything in terms of psi, so you want inch squared in the bottom. And to do that, you're going to need to do the unit conversion. 1 foot squared equals 12 squared, or 144 inch squared. And that will cancel your foot squared. And that leaves us with pound force per inch squared, pound force per inch squared. And now we can do algebra pretty much. And your P3 is going to be, after doing algebra, it's going to be 8.73 psi. And that is our answer. So this is the pressure. This is the gauge pressure at surface AB. If you swim down all the way to surface AB, this is the pressure that you're going to be feeling, 8.73 psi.